Welcome to this lecture series in complex numbers. In this lecture, we look at an application of what we have seen so far to a certain trigonometry problem. So what we will show is that if suppose n is an integer at least 3, and that's just for convenience, then this trigonometric sum, which looks quite daunting to me anyway, is equal to cotangent of pi by 2n. So all this thing miraculously turns out to be such a simple expression. And we'll do this using complex numbers. So here is the way I want to show it. So what we have is sine, so the angle pi by n is, or can also be written as 2 pi by 2n, and let us call this theta. So the summation that we are interested in is sine pi by n plus sine 2 pi by n plus dot 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 sine n minus 1 pi by n. This is what we are interested in. First of all, I'll just add one more term to it, which is sine n pi by n, and this doesn't make a difference because this is pi and sine pi is 0, so it's just convenient to add one more term. It looks better. All right, this is the sum that we're interested in, and this is nothing but sine theta plus sine 2 theta plus dot 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 sine n minus 1 theta plus sine n theta. So fine, I mean, we haven't done anything so far. So here is a key step. Let zeta be equal to cos theta plus I sine theta. And here is something that we know. Then zeta square, zeta cube up to zeta to the 2n are all the 2nth roots of unity. I mean, not that we need to know this really, but I just wanted to spell this out. Okay, so the required sum, let's call this equal to S. So thus, this is just a side comment, so let me gray it out. So thus, S is equal to imaginary part of zeta plus imaginary part of zeta square plus dot 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 imaginary part of zeta to the n, right? Because imaginary part of zeta is sine theta, imaginary part of zeta square is sine 2 theta. That's by De Moivre's theorem, or however you want to see it. So that's our sum, and of course this is equal to imaginary part of zeta plus zeta square plus dot 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 zeta to the n. And now we can use the formula for the geometric series. So the right hand side is nothing but first term times common ratio to the power number of terms minus 1 divided by common ratio minus 1. So that's what that is. But what is zeta to the n? So let me record that here. Zeta to the n is cos n theta plus I sine n theta, which is equal to minus 1. Yeah, I hope so. Yeah, I think this is equal to minus 1 because cos of pi is minus 1 and sine of pi is 0. So that's that. And therefore, this is equal to imaginary part of minus 2 zeta divided by zeta minus 1. Or we can also write this as imaginary part of 2 zeta, or twice of the imaginary part of zeta divided by 1 minus zeta. So this is basically we want to compute. So how do we do that? And the rest is just basic algebra, sort of, or trigonometry. Forget about this line, I can't get it right. So but twice of imaginary part of zeta divided by 1 minus zeta is equal to, let me get rid of the denominator. So this is equal to twice of imaginary part of zeta, 1 minus zeta, 1 minus zeta bar, 1 minus zeta bar. And by bar I mean conjugate. So this is of course equal to twice of imaginary part of zeta 1 minus zeta bar divided by modulus of 1 minus zeta whole square, which is equal to twice of imaginary part zeta minus zeta zeta bar, but zeta bar is that, which I'm sure you notice is equal to 1. But anyway, let me write it that way. So what is the denominator here? So the denominator is 1 minus cos theta plus I sine theta, and that we are taking the modulus of and squaring it. So this is what we are interested in. This is equal to twice of imaginary part of zeta minus 1, because mod zeta is 1, zeta is the root of unity after all. And the denominator is 1 minus cos theta whole square plus sine square theta, which is equal to twice of imaginary part of zeta minus 1. So yeah, okay, so let me substitute what is zeta. Zeta is this is cos theta minus 1 plus iota sine theta divided by, so let's manipulate the denominator, basically opening the brackets. We get this is equal to that plus or minus 2 cos theta plus sine square theta. So that's the denominator, and this is equal to, so since the denominator is real, the imaginary part of this is, as I'm sure we can see, is the following. It's nothing but sine theta divided by 2 minus 2 cos theta. So let me explain how I got the denominator equal to that. Basically, cos square theta plus sine square theta is equal to 1. 1 plus 1 is 2, and therefore we get this. So I hope you see that. And this is equal to sine theta by 1 minus cos theta. We just cancel the 2. And now there must be some formula for cos theta, which I don't remember offhand. But yeah, so yeah, okay, let me do that. So cos, yeah, okay. So cos theta is cos theta by 2 plus theta by 2, which is equal to cos square theta by 2 minus sine square theta by 2, which is equal to 1 minus 2 sine square theta by 2. So yeah, so this is the formula that we will use. Cos theta is equal to that. All right. So the numerator is 2 sine theta by 2 cos theta by 2. This one I always remember. So all we have used here is that sine 2x is 2 sine x cos x. That's what we used to write sine theta is equal to that. And the denominator is twice of sine square theta by 2. How do we get that? We just use this formula that cos theta is equal to 1 minus 2 sine square theta. If you substitute here, you'll get that. And now we cancel things out. So this cancels away, and this cancels away, and therefore this is cot theta by 2. So what we get is this is equal to cot theta by 2. So our sum is cot theta by 2. And what did we want to show? We wanted to show this is equal to cot pi by 2n, but what is theta? Theta is pi by n. So this is equal to cot pi by 2n. And that's it. That's the proof. So I hope we followed all the steps. Basically, once you get here, I mean, once you get the idea that you can just think of this sum as imaginary part of some manageable geometric series, rest just works itself out, basically. A little bit of trigonometry is used, but this is nothing. Yeah, so I think this is all. With this, I want to end this lecture. As usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.